Hello, I'm Simon, also known as Polyhop. Today we'll be focusing on the twist pop, specifically how to use it when working with copied geometry. Want to twist on different axes per copy. It was inspired rather directly by Jan Legal's harmonic twist piece. This is very much an exercise in recreating that Houdini piece in TouchDesigner. I found it to be a concise example demonstrating kind of a compelling use of the twist pop, so I thought it would be worth the exercise. And it also led to some interesting exploration, such as incorporating a camera input, which is a bonus example that can be found over on my Patreon. This tutorial uses build 2025 31550. So if you're using an older or newer version, there might be features that don't work in exactly the same way. And this release of TouchDesigner also marks the official release of Pops into the stable build. So I'm saying goodbye to my Pops experimental series and returning to form. Before I begin, I want to thank all my Patreon supporters and give a special thanks to my top supporters. On Patreon, you'll gain access to exclusive example files, tools, you can vote on future tutorial topics, and more. So yeah, let's get started. All right, let's go ahead and start with a base comp here. So this is what we'll work inside, and I will throughout be exposing some parameters to the top level just so it's a little bit more of a tool that can be manipulated. We can go ahead and call this twist pop or another name of your liking, and let's jump inside. Okay, so before I build this whole system, I want to just quickly demonstrate with a few pops what the twist pop does. So we'll start with a tube pop. This is what we want to twist, and I'm going to give it less columns. So let's do 4. Close to a box, but we do want to keep these rows. That'll make it look kind of nice, have some definition when we actually twist it. So I'll go ahead and set this to 100. And if you want to see this view, that's just toggled with W to get the wireframe view when the viewer is open. So let's drop a twist pop down, and it starts off with the operation twist. That is what we want. You can try the other ones if you'd like. They do different things. And then for our primary axis, we want to twist it around the Y. That's the green. And you'll see right off the bat, if we increase the strength, we get our twist. So that's basically it. You can also drop down a normal pop to recalculate the normals since they don't really look right in the twist pop. And I'll go ahead and choose a vertex for the attribute class. I like that. Gives it a little more definition here, and there we go. So this at the core is what we're going to be doing. So I'm going to delete these last two, and we will start with the tube and see kind of what the implications are once we actually copy a row of these to create our final effect. So I'm going to start by adjusting the radius slightly. This doesn't matter a whole lot, but I will keep it to kind of a 1 by 1 by 1 size so that we can have a little bit more clarity on how we're transforming it later. And I will increase the rows to 1,000, though you can always drop that down if you're having any performance issues. And then I will right click on the twist pop at the top here under Project 1 Twist Pop to customize component. So this is our parent. And I'll drag rows over here and bind new pairs master. So this is the process of exposing some of those parameters at the top. And if we go up a level, we'll see rows here. I might rename this, so tube rows, just so I know exactly what I'm doing. And I pasted that into the parameter, so we'll now see tube rows for our tube. Cool, I'll close that. And let's go ahead and also add a transform. I'm going to use this to actually transform the scale of our final tube. And before I do that, I want to rotate our previous step by 45 degrees in the y-axis so that our tube is now aligned to the axis. That way we can scale it without kind of skewing it. So I'll go ahead and customize my twist pop again and just drag scale over here, and again bind new pair as master, and then rename this tube scale. Again, I can copy and paste that into parameter to rename it. And then for this final scale, I'm going to choose some numbers that I know sort of work based on what we're going for here. So I'll do 0.25 by 4 by 0.06. So we get this tall rectangular tube. Yeah, now we've got our transformed tube. And I'm going to want to copy this and create a row of them. So to do that, I can start with a line pop. This is what we'll use to define our start and end point, as well as the number of copies with the divisions per segment. So again, customizing that parent component. And here I'll create a float. I'll call this copies width, which will represent like the length of the line. And I also can grab divisions and drag this in and bind new pair as master, and maybe call this num copies, and then renaming that. So I mistyped this, copies. Here we go, copies width, and I'll go up a level and just give this, maybe we'll set this to like 3. For now, we can always change these numbers later based on how it looks. And I'll close this out. And then to actually use that copies width parameter under position, I'll type parent.pair.copies width divided by -2. And for our second point, let's divide it by +2 and set y to 0. So now it's going from like -half to +half of the width. And then I can drop a copy pop. And that first input is the data or geometry we want to copy. And then the template is our second input. And right off the bat, we have our copies. We might want to reduce the number a little bit, or maybe we can increase the width slightly. Maybe to like 3.8. And we can also reduce the scale a little bit if it's too thick. There we go. So now we have a row of 20 copied tubes. And before we move too much further, I'm going to drop this into a geocomp and then set up the view so we have a geometry viewer on the right. So you can split left, right, or with Alt left bracket, and then also choose the geometry view. Great, so yeah, now we want to twist these. And if we just drop a twist pop down and make those same changes to the primary axis to Y and increase the strength, you'll immediately see why it's not really doing what we want. There's an order of operation issue because the twist pop is twisting everything on the Y-axis. But what we want is each of these tubes to be twisted first and then translated. So it's a bit of an order of operation issue. And the nice thing about pops is that we can store information as an attribute to be used later. I'm finding myself using this more and more, where I can pre-calculate things that don't need to cook and then eventually utilize them later, or do things like this where I need to twist it first and then translate, but I also want to have it copied. So there's this kind of like order issue. So in this instance, let's pass this position in as a template attribute, but we're going to avoid translating it at the copy stage. So to do this, after our line, we can right click, choose the attribute pop. And this has a whole lot of options for working with attributes. What we want to do is duplicate our position and I'll rename this something like translate. Now, on our copy pop, let's turn off our template translate. So we're not translating it anymore, but then under template attributes, we'll turn on use template attributes and choose translate. So now our output has that same translate float 3, and that is being applied kind of per copy based on each point. And now to actually translate this after the twist, we can use a math mix, and we'll use the operation a plus b using p plus translate. And there we go. So now we have an independent, like it twists first and then it translates, even though we're setting that translate kind of way back before our copy. So this can be handy in a lot of situations, and I found it important for actually working with the twist. Now we can go ahead and add that normal pop I talked about earlier to recalculate the normals so the lighting looks correct. And I like vertex, so we'll use that for now. You can certainly choose point if you'd like, but it gives us that nice edge so we can really see the definition of our strips. Next, I'd like to add some animation to this and also variation so that they're not all twisting the same amount. We can do this in a similar way to the translate attribute, where we pass an attribute in the template input for how much each of these strips should twist, and we'll feed that into the weight attribute of the twist pop. So I'm going to do this with a pattern chop, and we can keep the sine wave. I'll rename it twist and then drop a null down. And now we need a way to sample that with our line. So what I can do is I will create a normalize pop, and I'm going to use the X position, so p.x, and set this to parameter size 1, and then give it a different name. I'm going to call this lookup. And you'll notice now it's not actually normalizing our position or modifying our position, it's just creating a new attribute called lookup. I'll right click here and use lookup channel. So this is designed to work with a chop. And I'll drop our null in to chop, and then for lookup index attribute, I will choose I'll choose lookup. Should see nothing because we still need to name our output attribute scope. So I'll call this twist, and now we see our twist showing up as a point attribute. Similarly, we want to choose twist in our names. So you can just use that with the dropdown. And now we have our twist attribute that can be dropped into the weight. And yeah, there we go. Right off the bat, we are already getting different levels of twist per strip. So that's great. We can go ahead and add some animation to this now, so it's less static. So I like to use the timeline because it's a nice way to create looping animations, things like that. So I will drop down our timeline chop and choose end as well as frame. After that, a math chop set to divide channels. So we have a nice little fraction along our timeline. I'll drop a null that I call fraction, color that, and then we can use this in two places. One is to animate the pattern's phase. So if I drop this in and chop reference, get some nice animation. You could set the number of cycles down to even 1/2. I think that this, yeah, it does actually perfectly loop. I'm not sure if my example had 2 or 1, but that's just like an option, is you can adjust the number of cycles to get different kind of concentrations of twist. And then also another detail I like is rotating our initial geometry so that like these ones that aren't rotating at all, like everything kind of twists all at once. So I'll just drag this into rotate, chop reference again, and then this we want to multiply by 360. So pretty subtle, but now you see like that they're all rotating slightly. All right, let's go ahead and render this thing. So let's close our geometry viewer, and I'll rename this to twists just so that our geometry has a name. We also want a camera and a render top, and I'll go to the resolution parameter and set it to 1080 by 1080 for a square. And we can expose our resolution parameter on the parent as well. So right-clicking on Twist Pop, Customize Component, and then drag our resolution over and bind new pair as master. And we also, while we're at it, we could grab our twist strength. Realize that's something I missed doing, so let's bind that as well. We can call this twist strength and set some sections here for tube rows, and I'll also set strength as a section. So now we have these lines that can kind of divide things based on their function. I also want to set up this view so I can see what we're doing a little bit better. So I'll drop an out, turn on the display flag. We'll also split left right, and I'll split top bottom. And our top right, let's use the top viewer. The bottom right will go up a layer to the twist pop and choose parameters and drag this middle over a bit. And then on our left, right click display, backdrop tops off. So now we have a view of our output, and we can also see our parameters and play with those. So let's add some lighting to this. I can go ahead and start with a light. And there we go. You can see some stuff happening. I want to add shadows to this, and I'm going to do that before I go into PBR materials and add the environment light, just because it'll be a little easier when we can really see what we're doing. So first I'll create a rectangle pop, as we need something to cast shadows onto. I'll right click and add a geometry comp after this and call this like BG for background. And then displace it slightly, say like 0.5, negative 0.5 rather, and increase the size. So set this to 5 by 5. Now under our light, let's go to shadows and turn on soft 2D mapped. So we can see those happening. They're really rough around the edges. And this is something that I always do when I'm using shadows pretty much, is increase this shadow resolution. So even times 4, so it's 4096 by 4096, is giving us much nicer shadows. And then I can also increase the light size to say 0.35 just to get a softer look. Now that we have our shadows, I want to add some PBR materials and an environment light. So let's go ahead and add those for both our twists and our background. And copy that and drop this in. And it's really dark, so we'll see it kind of brighten up a little bit as we go. But let's start by adjusting the metallic for our strips to say 0.2 and then the roughness to 0.5. And I'm going to set the PBR material for the background, also pretty low metallic, say like 0.1 and 0.9 for roughness. So we still see our shadows there. It'll get, I think, a little bit, it'll become more subtle once we add the environment light in a moment. So I'll go ahead and do that. I'll drop down a movie file in top, and I've already downloaded an HDRI from Polyhaven, so I'll link to that one in the description. It's a great resource for HDRI that you can use as environment maps. So that's in my assets folder. And even if I just like point it at the folder, it'll load it. There we go. I'll drop a null after this, call this environment map. And then let's actually create our environment light. And we'll drop the environment map on. Cool. And so it's already looking more interesting, I think. You get like a little bit of color happening and variation within the twists and the reflections. And yeah, so one thing that I also want to point out is it all might feel like a little bit darker than you'd expect. And I cover this a lot more in my previous tutorial and really dive into like linear versus gamma color spaces and workflows. But our HDRI here is in linear space. And so we want to ultimately convert that to gamma or sRGB. So we treat this also as linear. So I'll right click and add an open color IO, which is a nice built-in way that we can do a color space transform. So I'll use pre-transform in color space. We'll say that's linear rec 0.709 sRGB. And for out, let's use sRGB. So it lightens up quite a bit. That's pretty nice. And I think for our background, I brought this down to say 0.1 in my example. So it's this kind of dark gray, but you can still see a little bit of the shadow. It's pretty subtle, but it's still there. Cool. So next, I will add some SSAO or screen space ambient occlusion. This is a pretty heavy effect, so you might have to dial this in based on your own system's hardware. But I tend to increase the sample directions and steps to maximum. I'll bring down the surface of void angle. I'll bring the SSAO pass resolution to full. It's often helpful to toggle off combined with color so we can see what's going on. And then I'll also bring down the blur radius to 0. Yeah, it's pretty close. We could, adjust this based on your own liking. There's some artifacts in there, so bringing down the contrast can also help. And then, you can always increase this surface of void angle as well. It can sometimes reduce those artifacts. And then eventually, combine it with your color, and you'll see that it's a very, again, once it goes through the color transform here, pretty subtle, but toggling it on and off, you'll see that it adds a little bit of that shading, especially where there are twists happening. And like if we made this really extreme, then you'd also see it, like especially in those areas of density. So that's it for our rendered setup. I also want to just touch on some of the things you can play with in the exposed parameters. I find adjusting the tube scale is interesting, especially if you set the X and the Z size to the same. You get this more uniform tube versus a thin ribbon. Also, by decreasing the thickness of the ribbon, you can increase the number of copies without them colliding. Changing the resolution, I think, has a pretty big impact here, and it's easy enough to increase the Y scale and the width if you want it to go full border. Some of the other things that I think are handy and kind of fun to play with, the PBR materials, like increasing the metallic and bringing the roughness down, will give you more of like a metal quality. I think going too low, you get some strange kind of reflection artifacts, but it's sort of a sweet spot that feels really metallic. Or changing, say, the color can give you some kind of like dramatically different feelings. So those are some kind of like quick suggestions, but certainly, there's a lot more I think one can do with the twist pop. So excited to, see what people do, and hope you enjoyed this tutorial on it. As I mentioned in the intro, I also did some explorations where I plugged a camera input into the system, It requires a little bit of a different method for sampling the twist attribute, and you can also add color in that same way. So if you're interested in trying it, it's a pretty fun exercise. Or if you want to just jump to a finished working version and see how it works, I've also included this example over on my Patreon as a bonus example. So yeah, just thought I'd mention that. It's located there in case you're interested in adding this kind of camera-based interactive input. So again, hope you enjoyed this tutorial, and thanks again for watching.